All right, so we're going to look at simplifying radicals. Some of this stuff you have done, and some of it will be new. I'm going to start with the older stuff first, just to review with you a little bit. And so we're going to look at 3 problems side by side. So first of all, let's take a look at the square root of 32, the cube root of 32, and the 4th root of 32. And so the goal is to simplify, and we have done some of this already. When you're simplifying a root, so let's start with the first one, the square root, you're going to want to break down that number. So 32 is 2 times 16. And you're looking for a perfect square. We see already we had 16 as a perfect square. We can use that. But you can, if you didn't notice it, you can continue to break the number down, and you end up with 5 2's. So the prime factorization of 32 is 2 to the 5th power. And then you're looking for which factors would make a perfect square, and so we're doubling things here. So 2 squared and 2 squared as well would make 2 perfect squares, and then we have a 2 left over. So the square root of 32 is the square root of 2 to the 4th power times the square root of 2. The 4th power would be right here, and then the leftover part I'm separating. That's the part we're not going to be able to reduce. So what's the square root of 2 to the 4th power? 4, or 2 squared. And by default, our root here is 2. And if you divide your power by your root, so divide the 4 by the 2, we end up with 2 squared, square root of 2, or 4 root 2. Okay. And there are other ways to get 4 root 2, but I'm just demonstrating one way to go about this. Okay. So on the cube root of 32, well, we break down the 32, and again, we get 5 2's. But now we're looking for a perfect cube, not a perfect square. And to create a perfect cube, you multiply the same number by itself 3 times. So 2 times 2 times 2 would create a perfect cube, which is 8. And then I don't have enough to create another perfect cube. So I'm going to separate them. The first ones that I circled, I'll put underneath the cube root. So this is the cube root of 2 cubed times the cube root of what's left, 2 squared. Okay, so the first one we can find, which is what? 2 to the which power? First power. So if you divide the power by the root, you get 2 to the first power and then the cube root of 4, or 2 cube root of 4. So try the 4th root of 32. You should be getting 2 times the 4th root of 2. Okay with that? Okay. So I'm going to give you another one similar to these, but now let's put a number in front. So say we had 3 times the square root of 48, and then 3 times the cube root of 48, and 3 times the 4th root of 48. What do we do as we're simplifying a root and we were pulling some numbers out of that root? What do we do with the number in front? What's that? Leave it alone? Okay, so if I'm working with square root of 48, I'll drop down. I get 4 times 12 2 times 2 is 4. 2 times 2 times 3 is 12. Okay, so I'm trying to simplify the square root of 48. So leave the 3 alone right now, right, in this process. And I have a couple 2's here. I got 4 of the 2's, and so I end up with 3 on the outside, the square root of 2 to the 4th power. I'm going to be able to simplify that part. And I have the square root of 3 that I won't be able to simplify. And square root of 2 to the 4th, we did that in the previous problem. We saw that was 4. But what am I going to do with the 3 and the 4? Multiply them. Okay, so that just making sure that's what you're going to want to do, not add them. So it's going to be 3 times 4 times the square root of 3, which is 12 root 3. So try simplifying the next two, the 3 cube root of 48 and 3 times the 4th root of 48. All right. So 48 is going to break down the same way as it broke down in the first one. So we end up with 4 2's and a 3. But now we're working with a cube root, so we're trying to find a perfect cube. So we're going to take 3 of the 2's here. There's already a 3 on the outside. We don't want to lose track of that. I'm going to take the cube root of 2 to the 3rd power here. And what's left is the cube root of 2 times 3, or I could put the 6 there. So we're going to end up with 3 times, what's the cube root of 2 cubed? 2, cube root of 6, so 6 cube root 6. How'd you do? Okay. Okay. And then the last one, we have, again, 4 2's and a 3. When you break down the 48. We're looking for a 4th root, or sorry, something to the 4th power. So 2 to the 4th power will work for us. And we're left with 3 times 2 to the 4th root of 3, or 6 4th root of 3. Okay. So is this coming back? You guys remember doing this kind of stuff? A little bit? Okay. So what if we're taking the square root, cube root, or 4th root of a negative? Okay. So in this unit, we're not going to want to work with imaginary numbers, but we will get, so we only want to work with real answers. And so is the square root of a negative 16 real, or will it be imaginary? Be imaginary, and we know that one. What is it going to be? 4i. So this is not real, and you guys could find out what that is. That's going to be 4 times I. How about the cube root of negative 16? Is that going to be real? So could you take a cube root and get a negative answer? Yeah. So if your root is odd, so it's a cube root to the 5th root, the 7th root, you're allowed to take that root of a negative number, and you'll get a real answer. And so this one, could be, we can break it up a few different ways, but we can think of this as a -2. We can have 3 -2s and one +2. But if you were to multiply that together, that would create -16. And the reason I'm putting 3 -2s is because that's what I'm going to want to pull out. I want to get the negative out from underneath the cube root sign. And so I'm going to be left with that +2. So this is the same thing as the cube root of -2 to the third power times the cube root of 2. And that's -2 times the cube root of 2. Okay. So you can take the cube root of a negative and you'll get a negative answer. How about the fourth root of a negative? That's not going to be real, okay? Because if we take any number and raise it to the fourth power, it has to be positive. And this is actually much more complicated to find out what it is equal to. It's not going to be 2i, okay? But in a more advanced math class, you learn how to find something like that, okay? All right. So again, we're just wanting to work with real numbers, and where things are going to so we're going to want to remember a couple things here. So first of all, even roots. So it could be square root, fourth root. In this unit, I think that's as much as you'll get, but any other as well need a positive answer. Okay, so that's going to be important to remember. Whereas odd roots, so the third root or the cube root or others, can give you a positive or negative answer. And we're going to now take the root of a variable, and we're not going to know if the variable is positive or negative, and so we need to keep that in mind as we're simplifying through this. And so I'm going to start with the square root of x squared. You guys remember what this was equal to? What? No? No? Yeah? No? The absolute value of x. So, and let's talk about y in a second here. So let's say so x could be positive or negative. We don't know. Right? And so that the reason why it's wrong to say that the square root of x squared equals x is because, well, what if x is negative? You can't have you can't take a square root and get a negative answer. And that's what we wrote up here. Even roots need a positive answer. And so that's why I'm putting absolute value around that, just to make sure I get that positive answer, because I don't know if x is positive or negative. What if we had the cube root of x to the third? Do I need a absolute value around that? No, because it's an odd root, and odd roots can give positive or negative answers, and so we don't need to put the absolute value around that in that case. Okay. Let's see. We're going to compare three things. So the square root of x to the fourth, the cube root of x to the fourth, and the fourth root of x to the fourth. So the ones you need to be worried about are the even roots, worried in the sense of, should I put the absolute value or not? If you have an odd root, there's no worries at all. You're not going to have any absolute values in your answer. Okay, you don't need a positive answer. So our root here is 2, and so we divide our power by the root, and so 4 divided by 2 gives me 2, so I get x squared as an answer, and I need to make sure that's positive. But is x squared already positive? Like, if x were negative, would x squared give me a positive answer? So do I need to put the absolute value around? No. So if, in this case, we don't need the absolute value because we're squaring a number, and when you square a number, squaring a number gives us a positive answer. And so that's why we drop the absolute value. Okay. On the next one, so we have 4 x's. I'm going to split them up to 3 and 1, right? Because we're looking for perfect cubes. And the cube root of x to the cubed is x. And can't do anything with that one, so that's my final answer. Don't have to worry about the absolute value because it's a cube root, and I'm allowed, if x were negative, that would be fine. I can have that as an answer. And then what about the 4th root of x to the 4th? Absolute value of x, and do I need to keep it? Yeah, because if x were negative, we would have a problem if we dropped that absolute value. Okay. All right. Let's try the square root of x to the 5th, cube root of x to the 5th, 4th root of x to the 5th. So on the square root of x to the 5th, I'm going to split that up to something I can take the square root of. So square root of x to the 4th times the square root of x. Square root of x to the 4th is, we already did that, right? We got x squared and the square root of x. Now, do I need an absolute value? Okay, and there's actually 2 reasons I don't need one here, and in understanding both reasons is going to be important for you. So let's list them both here. So we don't need the absolute value. What's one reason? Because x is squared. Or the other one we can use, and the other one's going to be important later on when we don't have x squared. Even if x weren't squared, I could also in this one say that we don't need the absolute value because I know that x has to be positive in this problem. Because if x were positive, what would happen here? You'd end up taking the square root of a negative number, and then we'd have imaginary. And I've started saying everything in this unit we have to work with just real numbers, and so that if x were negative, we would end up working with imaginary numbers because of the square root of x. So here's another thing we know: x is positive. Otherwise, the square root of x would be imaginary. And really, these are the only 2 things you look at when you're trying to decide, do I need an absolute value or not? You look underneath the square root and say, do we know enough information to see if x has to be positive? If it does, then we don't need an absolute value. Or when I pull it out, is it squared already? So if it were negative, I'm still squaring it, I get a positive answer. On this one, we don't have to worry because it's a cube root. what's the answer going to be? So we split it up, right? So we get x cube root x squared. And x is allowed to be negative here because the root is odd. Okay, how about this one? We got the fourth root of x to the fourth times the fourth root of x. What's the fourth root of x to the fourth? X. And then the question is, do we need the absolute value or not? So we don't have the x being squared, right? But what about this? This argument says, but does x have to be positive in this problem? Because if x were negative, then I'd have a problem here. Because I'd be taking the fourth root of a negative number, and that would lead to an imaginary answer. And so because of this thing, I know x is positive, so I know that's positive. So I don't need the absolute value. It's a little confusing, I know at first, that argument, but that's what I'm looking at. So if this were negative, I'd have an issue here. And so I don't need an absolute value because of this reason. Okay. And I'll even write that. So don't need absolute value. We know x must be positive in this problem. Okay, so I'm going to throw more at you here. So let's try the square root of x to the 6th, y to the 7th, z to the 8th versus the cube root and the fourth root. Yeah. So when you have multiple variables, it's just like doing multiple problems in one. You still do the same thing, and you still have to think about now we don't know if x, y, or z is positive or negative to start with. They could be positive or negative or a mixture of that. And so we just need to think a little bit more on these. So here I'm going to split it up into stuff I can take the square root of. So I could take the square root of all of x to the 6th. How many y's can I get rid of? Can't get rid of all 7. Because you're thinking, okay, on my roots 2, what can I divide out of 7, right? I could divide 6 of them. I can't divide that 7th one. And then z to the 8th. So we need these powers to be even. And what's left? Y. So if I were to multiply those together, I'd end up back at where I started. All right. And so I'm going to take the square root of all of this, and really what's happening is you divide all those powers by 2. And so I get x to the 3rd, y to the 3rd, z to the 4th. And I'm left with the square root of y. Okay. And then we need this, before we leave this, we need to ask, do we need absolute value? Well, we started with an even power, so I need to make sure my answer is positive. So do we know, so what do you guys think? Absolute value anywhere or not? Does a z need an absolute value? If z were negative, would z to the 4th be positive? Yeah. Could z be negative in this problem? Yeah. So Z could be negative, but even if it were negative, Z to the fourth would make that positive, so we don't need the absolute value there. Okay. Could Y be negative in this problem? No, why not? We'd have an issue if Y were negative. So because of this is telling us, hey, we can't have Y be negative because otherwise we'd have an imaginary number here. So we know Y has to be positive, so there's no worry here. Y to the third is going to be positive. Could X be negative? Yes. If X is negative, will X to the third be negative? Yes. So that's a problem, and so we need the absolute value around that. All right, so there's two questions you asked. Could the variable be negative? Right, answered with this piece. And if it is negative, will that variable to whatever power is there still be negative? So try, finish the next two. Yeah. So if Z is negative, right? So say it's like a -2. If I raise a -2 to the fourth power, I'm going to go negative times negative times negative times negative, which would end up making a positive value. So anything to an even power, even any negative number to an even power, will end up giving a positive answer. So this is the answer that we're looking for the cube root. We need absolute value anyway. Why not? Because it's a cube root. So just in the beginning, that's it. Don't worry about it. Okay. And on the fourth root, we're looking for powers of 4. So x to the fourth, y to the fourth, z to the 8th. And what's left is x squared, y to the third. Okay. And so when I take the fourth root here, I'm going to get x, y, z squared, because you're dividing your powers by the root. So 4 divided by 4, 4 divided by 4, 8 divided by 4. And we're left with the fourth root of x squared y to the third. And so for each variable, you ask two questions. Does that variable have to be positive? And if it doesn't have to be positive, well, is that variable to that whatever power is over here, is that positive? So let's look over here first. Where we look first. So does y have to be positive? If it were not, okay, in this problem, if y were not positive, well, let's start with x. Does x have to be positive? What do you know about x squared? X squared is positive no matter what, right? So even if x were a negative number, like x were -2, this would still be a positive 4. So x could be positive or negative and still make this work. But what's important for you to know is, okay, this is always positive. So we need y to be positive, right? So if y were negative, would y to the third be negative? Yes, it would be negative, right? So that's an issue, right? And so could y be negative in this problem? It can't be, because if it were, we would have, this would be an imaginary number, right? So y can't be negative. And so we don't need any absolute value for y. Y is good. Do we need an absolute value for x? Do we need an absolute value for z? No, because that's squared. Okay. Now, I'm going to teach you like a quick trick. Like here, this is understanding why we're putting absolute value around, but just a quick trick, if this is confusing for you, just how you know when to put that absolute value, that may be helpful to some of you, okay? Could x be negative? So then that's a problem. Because if I had a negative, I need a positive answer out here, so I have to make sure I get this positive. Now, y can't be negative, because that would cause an issue. So I know y is positive, and that's why I don't need the absolute value. Okay. So let me just show you, let's look back over what we've done, and I want to show you a pattern that may help you know when to use absolute value. And it's the even, odd pattern, okay? And let me explain what I mean by that. So I'm going to highlight the even, odd, just to point it out. So you only need absolute value if you have an even root, even power, and an odd power that it simplifies to. So even, odd. And let's just go back and look at all the ones that we put absolute value around. Okay, here. We got the even, odd. Okay. And so like with the y, I got even, odd, so no issue. Here I got even, but when I simplified, I had another even, so I didn't need it. Okay, so the even, odd is just a quick trick to know when to use that absolute value, or just to check. Here we have an absolute value. We got the even, odd, right? Which again is, why not here? Well, we got even, odd. It's got to follow the even, odd. So even root, even power underneath that root, and it simplifies to something with an odd power. So if that helps you, remember that even, odd. I want to look at a different kind of problem now. So solving. Start with something simple. So x squared equals 4. And I ask you to solve for x. How many answers am I going to have? 2, right? Because the power is 2, and whatever that power is, that's how many answers you're going to have. And we saw that with polynomials. So what are my 2 answers? Plus or minus 2. Yeah. And so some of you originally said plus or minus, and that plus or minus comes out when you're solving. And here's why. You end up taking the square root of both. And what's the square root of x squared? Absolute value of x equals 2. Okay. And when we're solving this, this is where we say, well, x could be positive 2 or x could be negative 2. Now we usually skip that. Sorry, I'm putting positive. It should be negative. We usually skip that step and just write plus or minus square root of 4. But this is really where it's coming from, and it relates to what we're doing here. So that's why I'm writing it. Often we'll solve it this way. We'll say x squared equals 4, so x equals plus or minus square root 4, or x equals plus or minus 2, and that's fine as well. Okay, but there's 2 different answers. Okay, how about this one? X cubed equals negative 64. How many different answers should there be? 3. This says third power. So we need to find all 3 answers. One of them's easy to find. The other 2 are not so easy to find. What's one of them? Negative 4 works. Okay. Negative 4 times negative 4 times negative 4. How are we going to find the other ones, though? So the way to go about this is to set it equal to 0 and try to factor it. Okay. So sum of 2 cubes which we factored before. And what's one of the factors going to be? X plus 4. And that one's going to give us x equals negative 4, which is what we were thinking. And what's the other factor going to be? X squared minus 4x plus 16. And this gives us our other two answers. And these will be imaginary answers, okay? But when we're solving, so when we're simplifying up here, no imaginary stuff, okay? But when we switch to solving, you can have imaginary answers, okay? And that's what we're doing right now. We're switching to solving. And so then we separate our factors, set them equal to 0. So x plus 4 equals 0, which gives us x equals negative 4. And then this one, x minus 4x, sorry, x squared minus 4x plus 16 equals 0. And we want to solve for x here. What do we need to do here? Quadratic formula. So go ahead and use the quadratic formula, simplify that, get an answer, find out what the other two values for x are.